Okay, for this video we're going over some basic integration rules. So let's say you started with the derivative of x to the n. This is our power rule. We take the n multiplied down to the x and then we would subtract 1. Well, let's say, okay, what if you're taking the integral of x to the n and this is with respect to x? Then I'm going to work the exact reverse. I multiplied down and subtracted 1, so I'm going to undo each of those steps but also undo the order. So I'm going to raise the power by 1 and divide by my new exponent, n plus 1, and add my constant of integration, c. Just to show you how this works, I'm going to rewrite this 1 over n plus 1, x to the n plus 1, and let's say I'm taking the derivative of this. I take my n plus 1, multiply it down. It cancels out with this n plus 1, and I'm left with an x. I subtract 1 from my power, it's x to the n, and then the derivative of a constant is 0. So the derivative of this is my x to the n, and you should always be able to check your antiderivatives by taking a derivative. So this works. Imagine that I knew the derivative with respect to x of sine x equals cosine x. Then what that means is that if I do the antiderivative of cosine x with respect to x, I should get sine x plus c. And you do. The derivative of sine x is cosine x. Now this opens your antiderivative statement. This dx closes it. It tells you with respect to which variable. It's also kind of a unit, and it has its own meaning as a differential. But the way I want you to look at right now is this opens a set of parentheses and that closes it. It's not being replaced with the plus c. A lot of people think that. That's not what's happening. The plus c is your constant of integration because the antiderivative gives you a whole family of functions. This just says, hey, we're taking the antiderivative with respect to x. To keep going, imagine you're doing the antiderivative. You take the derivative of cosine x, and that is negative sine x. So what happens if you do the antiderivative of sine x with respect to x? Then that will equal the opposite of cosine x plus c. And you can see that because if I take the derivative of cosine x, I get negative sine times a negative gives me the sine x. Then the derivative of the c is 0. A lot of students ask me, why don't I put the negative right here in front of the sine x? And you could. And then I just have a negative and this would be a positive. But generally when you go term by term, when you're taking antiderivatives, you don't look at the negative with it. I'm going to say, oh, it's, hey, the minus the integral of sine x dx. So it's really just how you look at a problem. Okay, the derivative with respect to x of tangent x is equal to secant squared x. So I'm not expecting you to know right now the antiderivative of secant x, but I do expect you to be able to say, oh, if I have a secant squared x dx, then I know the antiderivative of that is tangent x plus c. We'll learn what the integral of just secant x dx later when we actually know a little bit about logarithms and how to take derivatives and integrals using logs. The next one, the derivative with respect to x of cotangent x. We know the derivative of cotangent x, it starts with a c, so it's negative. The derivative of tangent is secant squared x, so the derivative of cotangent x would be negative cosecant squared x. So we're going to treat this one just like we did up here. I'm going to ignore that negative out front and say, what's the antiderivative of cosecant squared x dx? And that would equal negative cotangent x plus c. Now the derivative with respect to x of secant x is equal to secant x tangent x. And again, I'm not going to expect you to take the antiderivative of secant right now or tangent right now because there's nothing that you know how to take a derivative that just gives you those. But I would expect you to know the antiderivative of secant x tangent x with respect to x is equal to secant x plus c. The last one, the derivative with respect to x of cosecant x. It starts with a c and it's related to secant, so this is secant x tangent x. This will be negative cosecant x cotangent x. And then I would expect you know the integral of cosecant x cotangent x with respect to x is a negative cosecant x plus c. And those are just some basic integration rules. These are antiderivatives.